Write down question. Show that, write down, ग्रेविटेशन का डेरिवेशन है, ठीक है. शो दैट Kepler's, write down, show that Kepler's second law follows from the law of conservation of angular momentum. We have to show that Kepler's second law follow the law of conservation of angular momentum. Means Kepler's second law follows law of conservation of angular momentum. We have to show it. Write down. First, consider a planet. Write down. Consider a planet is moving in an elliptical orbit with sun at focus. With sun at focus. Okay. Now draw the diagram for this. It draws sun. This is sun. And draw an elliptical path around sun. This is elliptical path where planets revolve. Okay. Now suppose the planet is at this point. This point is P. And after some time planets comes to this point, that is P dash. So this is radius vector. This is R1. And this is R2. And this distance is delta R. It's radial distance between two planets. In the first, planet is here only. After some time it will move to P dash. P is the initial point of the planet. After some time it will move to P dash, and sun is at any point, that is focus of the elliptical path. Done. So we know that there is a force of attraction between planet and sun. What is that force? F is equal to G m upon R square. Here R is a distance between sun and that planet. Here P is what? Write down, this is planet. Okay, this is elliptical path. This is what? This is elliptical path. Now since it is moving along a circular path, so in circular motion we require torque. Okay, write down, in circular motion torque is required. Torque is required. And torque is represented by tau. So what is the formula for torque? Torque is equal to, so force direction is where? In this way force is acting, because gravitational force is attractive force. It always acts between two objects, that is object number 1, object number 2, and it is always attractive. That's why the direction of force is toward sun. Now you tell me, what is the formula for torque? General formula for torque. Torque is equal to R cross F. But here, what is the angle between R and F? You write here, torque is equal to RF sine theta. You tell me the angle between R and F. Here it is 0 degree. Why it is 0 degree? Because you see, R is in this direction, force is in this direction. So the angle between them is 180 degree. Sorry, 180 degree. It's 180 degree. So what is sine 180 degree value? Sine 180 degree value is 0. The value of sine 180 degree is 0. So we will get torque is how much? Torque is 0. Write down torque is equal to 0. Again you write, but we know that torque is what? Torque is rate of change of angular momentum. This we studied in rotation motion. Rotation motion, the torque is given by rate of change of angular momentum. Write down dl by dt is what? Rate of change of angular momentum. Angular momentum. Now you tell me only, when torque becomes 0, when torque becomes 0, it means the derivative of any constant is 0. We know this thing. It means torque becomes 0 only when L is what? L is constant. Because derivative of any constant is 0. So put here L is constant. That's why its derivative is d by dt of constant is what? You know this thing already. I have discussed this thing. Derivative of any constant is 0. So we'll get L is what? L is constant. Note down this thing. So L is constant. Then what is L here? Write down L is angular momentum. L is called angular momentum. Again you write, suppose the planet moves from position P to P dash, from position P to P dash in time delta t, then area swept. What is the formula for area? Half into base into height. So in this diagram you just see, first you note down up to this. So we'll get area swept, that is delta A. What is the diagram? You see here, in this diagram you see, when planets moves from P to P dash, it covers some area. This area is the area swept up to this area. So how to find the area of this term? Half into base into height. Height is delta R, base is R1. So put here half into base into height. So it's half. Okay, half. Base is how much? Base is, what is base? R1, or you can write R also, no problem. Into height is delta R. Delta R. Okay, but we know V is equal to what? Delta R upon delta T. What is V here? Velocity. What is delta R? Change in position. What is delta T? Change in time. So just put the values only. In place of delta r, you just put, in place of delta r, you just put, what you can put? Delta r is equal to V into delta T. This is equation 1. This is equation 2. So from 1 and 2, what is the area value? From 1 and 2. Therefore, from 1 and 2, from 1 and 2, we can write delta A, area, is equal to half, base is R, and in terms of, and delta, in delta R we will write here V into delta T. V into delta T. So what is delta A? This is delta A. Note down this thing. This is equation number 3. You make a box. Equation number 3. You tell me what is the formula for momentum? P represent momentum. So what is the formula for momentum? Momentum is equal to mass into velocity. Then what is velocity? Momentum upon mass. But what is area? Just now I derived. Area is how much? What is the formula for area? Half into R into V. Half into R into V. Okay. And next term is what? Delta T. So you put here delta T. In place of V, you just put the value of V. In place of V, you put the value of V. So we'll get area is how much? Delta A is equal to half into R into momentum into mass into delta T. Okay. So after, again you solve. Arrange it. A is equal to half into momentum into R, you can write. In vector form you can write R cross P. R cross P. And in denominator you can write. This delta T will come to this side. So here you will get M. Okay, this delta T will come in denominator of area. Now again you will get delta A by A. This is the second law of Kepler's, that is half. In place of R cross P we can write L, and here it is M. So everything is constant here. 1 is also constant. L is constant. Already I discussed in the previous section. Mass is also constant. And 2 is also constant. So overall this all value become constant. That is the area by delta T is equal to constant. It means this is the second law. This is the Kepler's second law, which represent every planet sweeps equal area in equal interval of time. Every planet sweeps equal area around sun in equal interval of time. Okay, this will take same. This is the second law. Same time, in same time it covers same area. Suppose in 1 second it covers 100, then again in 1 second it covers 100. Same planet. Planet P, planet P, planet P at different position. At every planet sweeps equal area in equal interval of time. That is constant for every planet. That is the Kepler's second law.